So she dropped the camera, and we had to sit here and put the camera back together because it just split into.
Holy crap! I think the microwave is leaking.
What do you mean it's leaking?
I mean, I think it makes this really loud radioactive noise, and I don't like it.
Radioactive noise?
I know we just got it, and I know it's new, but I think that it's leaking.
How does radioactivity put it down?
It's like, it was totally like radioactive sounding. Anyway, can we test it?
Why don't you bring the sensors?
Alright, here are the sensors. See how easily I found that?
How about that?
Yeah, you must be organized or something. Or they were out.
Yeah, wow. Here we go. No, this is clearly.
See how well it's labeled?
Sensors improved. Because
you're an excellent labeler.
Thank you. This is a pair of logic probes. This is a pulsar which sends the signal, and this is the logic probe itself. And the test.
Words?
Microconductors.
Oh.
So now we have. Oh, this is an SPO meter.
What does that do?
Sound. It tells you what is. You can set the decibels so that way you can.
What's this?
Oh, well, that's a battery tester.
It looks kind of cool.
It tests the little button batteries. It's an old analog voltmeter. Scale, pocket scale. Oh, this is another one. Then we have
1 pound.
And we have.
It's green.
Oh, it's a wall. It's a wall stack finder.
What are you doing?
It's an amplifier, stereo amplifier, listener, so you can amplify any sound around you.
What do you plug it into?
Your ears. Oh, this is the tire pressure.
How much tire pressure does it have?
It's just empty. It's just hot air. This, you actually just put your finger here, and you touch around any place that you suspect it to have a live, and it will tell you it is.
Oh, so check to see if it's a live circuit?
A live circuit, yeah. A microscope.
Ah. You still want to know what you're doing.
Will you see what we're doing? Come on. So here we are. We have a digital moisture meter.
How moist is the bird?
It is. Do we want to find out?
No.
How bad do you want to know this?
I guess it's not point and shoot.
No, it's pointed out. Another thermometer.
Ah.
But this is a mercury thermometer.
Hey!
Whoa!
Whoa!
Come on now.
He was chewing on a remote.
That's his favorite hobby.
Why do we always end up with pets that chew up the stuff we need for our projects?
Chewing everything. I like this one, and I'm going to use it for some of the hangings that we're going to do. The 3 picture frames, because this one's laser. Come on now.
Does it need batteries?
Ah!
This guy is like totally into what you're doing. Pika. My eye!
Oh! I never leave batteries in these things.
You did this time. You better do that over the trash.
Yeah.
Oh
no.
I told you to do it over the trash. Now you gotta worry about this guy.
I need to I need to make
Whoa.
What?
We need that back. We're
I
not
need
done
to-
getting the
yes.
sensors.
I need to get some baking soda
Mhm.
and a little bit of water, and you make a mix, and you neutralize all of that.
Okay, that's a mess.
It is a mess, but you do it with Q-tips. Where is he?
He's that away.
So
Right up
now
there.
we have this sensor.
What's this one do?
Creme de la creme. So these sensors, there was an actual article in one of the old electronic magazines, and they went. It was something like old timey, like Popular Electronics, and so this company used to advertise in the back of the magazines, and I always wanted one of these. And this was, it's the 4th of July.
Yeah.
And so this is a tri-field meter. It has it's a trimeter. It 3 types of bands and
Electric spectrum?
and the whole spectrum.
Okay.
So this one does the magnetic field from 0 to 100 milligauss, or an electric field 0 to 100 kilovolts meter. Magnetic field between 0 and 3 milligauss, and the bottom radio microwave spectrum. Microwave by centimeter square. So this will, in the front, the exclusively, you put this near a magnetic field, an electric field, a suspected radio field, or a microwave field, and it will give you the radioactivity range. Now,
Question. Say you get a reading on a microwave scale. What is the danger level? When do
well,
we need to run?
Well, this. They actually thought of this. This was made by Alpha Lab in New Jersey, and this was built way back in the day, and all of a sudden they completely just disappeared. So it was funny because this was by the time the company disappeared, they had sold several thousands of this, and this is one of them.
So this is rare.
This is rare. This is very rare. This is a treat. So, yeah, we can go check out the microwave and see between 0.1 and 0.1. That's what?
I'm looking to see it. Okay.
This is on the milliwatt to 1 watt range for the microwave.
And what are we supposed to have? Like nothing, right?
Well, yeah, according to this, yeah. But as we notice, every time that the dose gets worse, the more solid the line goes.
Mm-hmm.
It shouldn't even go that anywhere near that. It should be. We're talking about one what's that? One full wave of the microwave So the way that its frequency of characteristics is that microwaves are in the millimeter range. I mean, we're talking about very, very small wavelengths. And when the smaller the wavelength, the more penetration power it has. So that's why you have to line the microwave with a porous and an absorption type of material. So now it goes and it bounces, and that pretty much just keeps bouncing around. And when you have your food in the middle, this is what you're getting going into the food. That very short what's that? What's that? 0.1 millimeter. Yeah, it's a very small wave. So let's put me in the microwave and see what happens. In fact, yeah, let's see what happens.